Hey there. So today what we're going to be doing is we're going to be looking at using this UniFFI tool, FFI. We're basically going to be developing a little library in Rust that's going to make an asynchronous request out to the Star Wars API. And then we'll be bringing that information back in and then exposing it to Python, Swift, Kotlin via this UniFFI tool. Cool. So let's get started. So I just have an empty directory called Star Wars, and I'm going to create a new cargo library there. Start a Visual Studio Code. Okay, let's go ahead and look at the API. So we see right now the base URL is swapi.dev/API within people, and then it looks like some sort of ID. And it looks like they have planets, starships, returns, Luke Skywalker, and so I guess we can try. See who number 2 is. C3PO. Okay, cool. So I think for the I think what we can do is we can create a very simple OpenAPI definition and then generate the Rust client with that OpenAPI generator. So what we have here is just a Swagger editor, and so we're basically just gonna like rip out all this stuff. I think actually it might make sense to just reuse the existing get. Okay, remove tags. All right, so we change pet to character. And then, let's see, name, height, mass. So let's just use those 3. Let's get rid of this. Maybe we keep that. And it looks like these are all just strings coming back. So all right, and it's saying something about an API response. I think we're just gonna return the character straight, right? There's no nested objects here. Cool. So this is like just a very basic. We have a character, ID, name, height, mass, and then one endpoint that should mimic at least something. So let me also, yeah, name, height, mass should be cool for now. A slimmed down version. Okay, great. So I'm going to copy this and I'm going to bring this into our project. I'm going to make a new folder. OpenAPI definitions. And Star Wars API.yaml. Okay, cool. So here we are. We have our basic YAML file imported. And then for this, we're actually going to use Docker to basically use this OpenAPI generator. And so since we have the OpenAPI definition, we're just going to go run this Docker command. And what I'm going to do is I'm going to create a make file because I'm used to make files. So I don't really know the idiomatic way to do this in Rust and cargo and that whole thing, but we're going to do a make file. Build OpenAPI. Yeah, build OpenAPI. Cool. Except it's not going to be local pet store, it's local. We can actually just keep it named Star Wars. Okay, and then we will do the Rust generator, and then local generated. Yeah, we can just output it to local generated. OpenAPI. So what this will do is this will bring down the Docker image, and it will use it. Oh, it was not able to find it. Okay, I figured out what the error was. Okay, and so this will basically just create this generated, and we see that I added the package name as Star Wars. So if we go into the nested cargo, the package is Star Wars. Cool. All right, great. And so now what we can do is we can add that dependency to our main project. That's right. That's right. Star Wars. We're going to rename this as Star Wars API. Okay, and then now we're going to do generated. I think that is what's going to work. Great. Okay, so we see Rust Analyzer is happy at the bottom here. Cool. Okay, so the next thing that we're going to do is inside of here, we're just going to do like a very simple, like, can we call that API? So let's just do get character, and then we'll do an ID U32. Okay. And we're going to use Star Wars API models character, and so we're going to return a character. And so what we can do is we can say like character equals Star Wars API, APIs, get character. I guess we can change that as an I64. Okay. Okay, and so this is async. And so now we have to do an await. Okay, but instead of doing an unwrap, what we can do, yeah, we could just do an unwrap for now. Okay, and then we return that character. And so what we can do here is we can do Tokyo test. We can go to our TOML. And then in our dev dependencies, we could say Tokyo. Wow, a lot of things pop up. Yeah, okay, cool. So now what we can do is we can get a character. We can get ID number 2. And then this is going to be an async function. And then here we can do an await. Okay. And then what we can do is we could say character. And what we can say is character dot name C3PO. Okay, cool. And so this basically we're just using the async here, async runtime in our testing from this Tokyo package with dev dependencies only. And so when we run that test, it'll bring that in. So there's the Tokyo libraries. Cool. So it looks like it's happy. So at this point, we know what we can do is we can create a super simple Rust library that uses generated code to go fetch a Star Wars character and return that character. And so the next stage is to basically take this get character function and with this UniFFI tool, expose it for a few different languages like Python. And so if we go through the tutorial, there's a few different things we'll need. Yeah, so over here, we'll just kind of follow along. We're going to generate a dynamic library, and we're just going to call this library Star Wars, because that's what our main package is. So we're just going to match this library name. Okay, we'll also need a couple of dependencies. And so following suit here. So I think the latest version of this is 0.25. And then actually we will need features here. Okay, but then for here, we'll want the CLI. All right. Okay, so we've added this dependency, and we're not going to do a UDL file because I haven't had good luck with async stuff with UDL files. When apparently you can do an async annotation, like on a function, but every time I try to parse this file, then it's not happy. So we're going to be using the Rust macros. So anyway, just kind of moving forward, we will not need to do a build rs file. Yeah, so set up for crates using only the proc macros. So we'll grab this, and we're going to put this at the top of our library definition. And then we're going to name this Star Wars. Okay, and so now what we're going to need to do is instead of doing anything crazy with like cargo nightly, we're just going to create this like bin in our cargo toml file here, and we're going to change this path to be source, and inside source we'll create the bindgen file. This is just straight out of their doc, so we're not doing anything crazy here. And then we can name it whatever, but we'll just stick with the default name for now. We're not worried about multi-crate stuff or anything like that. Okay, So in their docs here, they basically, there's multiple different ways to do this, and basically they recommend using the generate library, and this will be the default. But the example they give is with the .so file, and so I think like if you're running on that platform, that makes sense. But if you're not running on that platform, it'll be something slightly different. So if we go into our make file and we do something like build FFI, right? And then let's just maybe call it Python. And the out directory will be, we'll call it like a Python SDK. Yeah, so in our target, we should be able to run this, and we'll see in our release directory that library pop up. Was there anything that I missed? Yes, with the UDL file, you just point to this instead of using the generate library option, but I never had luck with it, so. Right, and so we see we have a lib starwars, but it is a dy lib, and so that's the dynamic library for a Mac. Okay, and so now if we run this build Python, we should get this SDK Python directory with a Python file module, Python module, I guess. So SDK Python starwars.py, and so here, oh right, there was one thing I missed. Okay, so the UDL file, cool. We actually need to go to the procedural macros, and so we have this. We actually need to export the function. So that's why the function does not appear. If we go over here, UniFFI export. Right, so that's right. I forgot about this as well. I don't know if there's a way. To re-export models in Rust. I'm pretty sure there is. Or what is this? A struct. Yeah. So I don't know if there's a way to do that. So what we'll do is we'll create our own. And so we'll do that with the record. Something like this. Okay, so we'll call this my character. And my character is only going to care about a couple things. So name and height. This is also going to be a string. And then mass. And that's it. Okay, and so now we have the UniFFI derive macro. And so this is going to return a my character. And so what we'll have to do here is just pass this stuff into our own struct. Yeah. And then we don't need this model import. Okay. So quick recap, we have the export on the function, and then we have the export on the my character. So also one thing to notice is I'm calling the cargo build, which is going to do the UniFFI bindgen stuff to basically get this inside of this command. So I'm just running those two steps. So in starwars.py, we can see we're getting get character stuff. Right, and so here's our actual function, and there it is. There is one wrinkle that I've run into, and so since this uses request, and request uses Tokyo under the covers, we need to basically tell it like, hey, you can use the runtime for this. Otherwise, when we generate everything and call from Python, it's not going to be happy. And so we do one of these bad boys. Okay, so now the problem is Tokyo main, this macro does something interesting. If you have a function like this, um, it'll basically, once the macro is unraveled, it makes the function non-asynchronous and puts it inside of a runtime build all, enable build, blah, 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 block on with the async. So it's not async. And so this macro is now complaining. It's like, hey, this call returns my character. It doesn't return a future. Super, super, super annoying. And so what we can do as like a workaround, at least until I've figured out how to basically have the Tokyo runtime like lazily and statically linked, that can be used by any request like automatically. Until I've done that, I'm just gonna call this guy internal. And then over here, we'll have a regular get character. Oh, and then we need to add this to our actual dependencies. And then I think it's there's a couple other things. I think there's a net. Okay, so now instead of here, what we can do is we can just call return this dot await. Okay, and so now we have an async function that's going to be exported. And then here we're basically, until we have the Tokyo stuff figured out, we're just gonna like create a runtime every time we call this function and quit. Should be okay because we're not doing much there. And then here we export the get character. And this, yeah, until we can basically take the model and re-implement it and with this drive tag, like re-export it with the drive tag, it kind of makes sense to maybe have our own struct, at least for right now, that we return and we handle all that stuff there. Yeah, and so this could theoretically return the character model. And then here we can do the let character. And then return it. And so this is kind of like the function that we expose. It does the custom bits. Yeah, and so we'll import this. And let's just take this away. Import that as well. Okay, and so this internal character is like the full model character, and then we take it, we're changing it slightly, returning it here, and exporting this. So this is our custom function that gets exported to the Star Wars Python SDK. All right, so we still have our get character. I'll create a main Python here. Yeah, import Star Wars. It's not going to be Luke Skywalker. It's going to be get character 1. And then what we could do is we could do, but we're not going to need that. We're going to have to import async IO, and then we have okay. So in Python we have the async and await, and we're just printing the character name, and then we can run this. Oh, one more thing we need to do. We need to copy over the file. Cool. And there we go. Luke Skywalker. So hopefully a lot of that makes sense. It's nice because we also have this my character model exposed, and so like right here we can see this is actually my character, and if we look at this, we have a whole class defined for us in this module. Name, height, mass. Yeah, so we have that type. So I think we can do okay, something like this. And there we go. We basically are on our way to creating an SDK that works, built in Rust, works in Python. And then the very nice thing is we basically already have just support for these three right here. Apparently there is one wrinkle with Ruby, and the async stuff is not supported in Ruby. But yeah, it's kind of interesting because the whole Tokyo runtime and everything like that. So anyway, but we can at least do Kotlin, Swift, and Python using this UniFFI approach. Great. So in the next video, what we're going to be doing is we're going to be extending this to support WASM. And through WASM, we will support Node.js and the browser. And so we'll have this getCharacter function running in a Node and a JavaScript example. So stay tuned for the next one. So just one more thing really quick. If you run the tests, this is going to fail. And we need to actually get rid of the Tokyo here because that's going to create a runtime, a Tokyo runtime, and get rid of the async. And so this is now the working test. And so just to remember, just to dive into this a little bit more, if you hover over this main, it gives an explanation that the macro will take an asynchronous function like this, and this is the equivalent code not using that, right? And so basically we'll build the runtime and then do a block on the async function. And so that's why the test will fail, and we need to fix it by making it non-async, and then calling our internal getCharacter, which is the one. So now this will build the Tokyo runtime. Anyway, just last little update on why the tests were failing, and now the tests should be passing.